Okay, we are starting with trigonometry. You did a bit of trig last year, so it's not that you haven't done any trigonometry. Grade 11 is just going to be a whole new ball game. There's a lot of extra stuff that you have to learn and get used to. So it's going to feel like a big jump maybe from grade 10. But yeah, I won't say it's that big. But we have to get the groundwork done really well, and otherwise you're going to suffer. Okay, let's just look at the following. There's going to be many sections. Doing trig is like saying we're doing algebra. In other words, there's equations, there's exponents, there's a lot of different stuff. You use the same rules everywhere, but you've got different sections. So in trigonometry, you also have a lot of sections. We are just going to look at reduction values today. Reductions. And that's basically a method by which we take an obtuse angle, something like, say, for instance, 120 degrees, and we convert that to acute angle. So you start from obtuse angle, and then you convert something to acute angle.
Now, quick question.
Yes.
Are you writing anything on your screen?
I am.
I can't see anything.
Why can't you see anything? Oh, you know what? I'm not used to my screen pausing when I've got another page open. I must just get used to that. Can you see the screen now?
Yeah, it says reduction.
Okay. So we are going to work with reductions. Okay, but before we could do that, just let's refresh a couple of things. Last year, you did 3 special triangles. I don't know if you can remember them. Could you remember them? You had a 60 and 30-degree triangle. Could you remember that one?
Yeah.
Really? Could you remember the sides as well? Okay, so at a 90-degree, yeah. If this angle was 60 degrees, this one obviously would be 30, and then the length of the sides is 1, 2, root 3. Remember that? Yeah. If you're stuck, you just draw the triangle and you type in cos of 60 and it will give you 1/2. And you type in sin of 60, it will give you 3/2, or root 3/2. So the side length is not an issue. You can always figure that out in your calculator. Then you also had a 45-degree triangle. I don't know why this one is like not wanting to draw a triangle today. Okay. Okay, so there was a 45-degree triangle. 45, 1, 1, root 2. Remember that one?
Mm-hmm.
And then we had another one that really doesn't exist. I'm going to try and draw it differently. So we might try and make some sense of it. There was another triangle that was kind of doesn't exist, but it does help you because you haven't done graphs yet. It's a 90-degree triangle and a 0 degree. So you had 0, 1, 1. Okay, I'm going to copy those and we're going to just bring them along in our examples. So I'll just paste that. And then I can just take this out. I don't need this. It takes a lot of space. So those 3 triangles you have to memorize. Are they big enough to see at the moment?
Yes, I can see them.
Good. So last year we did something like this. We did sin of 60 degrees times, say for instance, tan of 45 degrees divided by cos of 30 degrees. And then we had to do that without a calculator. Could you remember that? So. Okay, with the help of those triangles, it's not that difficult because we can read sin of 60 from that triangle. Now, sin of 60 is what? Can you remember sin is opposite over hypotenuse?
Yeah.
Okay, that I'm assuming that you still remember. So that's root 3/2. And then tan of 45, it's opposite over adjacent, which is just 1/1 or 1. And then I can use cos of 30. Cos of 30 is adjacent over hypotenuse, which is root 3/2. And that answer is 1. Okay. So would you be able to do something like this?
Yeah.
Yes. If you do a little refresher on those triangles, you'll probably get to do this. So in other words, you know that tan is opposite of adjacent, you know what cos is, you know the ratio for sin.
Mm-hmm.
Okay, good. So we can actually discard this. Right, now, there's something new that you have to learn. This is like a system of axes. This is very important, and this is going to help us with our new work. So that's like a x and a y axis. Now, in trigonometry, we start off here on the x-axis at 0 degrees, and then we calculate or add anti-clockwise. So if we move along anti-clockwise, we'll get to 90 degrees there. Agreed. If we move a further 90 degrees, we'll get to 180 degrees there. And if we add or move further on, we'll go to 270. And if we add more or go another 90 degrees, we'll get to 360. Right. Obviously, if you subtract, you go the opposite way. Then you go clockwise. Happy with that? So clockwise is subtraction and anti-clockwise is addition. So an angle of, say, 180 plus x, where x represents a acute angle. Would you agree we're somewhere here in this section there?
Yeah.
Okay, good. Right, good. Now, these quadrants have names. This is the first quadrant. Its name is A. A is for all. This is the second quadrant. Its name is S. It's for sin. This is our third quadrant, and its name is T for tan. And this is the fourth quadrant, and its name is C for cos. So you can refer to it as a cos diagram, C-A-S-T, or we can just name it all stations to Cape Town or whatever you feel comfortable with. So you have to memorize that. I'm just going to copy this so that we got it and we can bring it along wherever we need it. Okay, I'm going to delete this. Okay, so what I want you to do is on a piece of paper next to you or in your book, you need to have those three triangles, special triangles. It's called special triangles. And you have to make a note of this. That's your section you're going to study. That we're going to bring along wherever we go now. I'm going to show you how to set up special triangles inside this system of axes and then get values. This part of trigonometry is very important. It counts a lot of marks. So is Ibrahim going to study to become an imam?
I don't even know what he wants to do, to be honest.
Look, it's still a great, when you're in grade 11, you still don't really know what you want to do because you're young and you haven't seen all the options yet. That's the bottom line.
Yeah.
Do you have an idea what you want to do? Or just like a glimpse or a small idea?
I was thinking of architecture.
Okay.
But the job opportunities is not so good in South Africa, so maybe psychology.
Good. Tell me when you're ready.
Yeah, you can move on.
Okay. Let's see what we've got here. Okay, you've got those drawings in front of you. I'm just going to draw from them. Maybe I should just copy this and move to the next page. Okay, so let's paste it here. Just going to make it small so we can use it. So now what we can do, if I have sin of, let's say, 240 degrees, I can rework that 240 degrees into the following. I can rework it as sin of 180 degrees plus 60. So I've changed the 240 degrees to what we call a compound angle. So it consists of 180 degrees plus 60 degrees. So in effect, what I'm doing the following. I'm taking my normal 60-degree triangle. 1, 2, root 3. And I'm actually moving it all the way to the third quadrant. What I'm doing now, I'm just going to explain something to you that is not really important for you to understand. Because there's a method of doing this without understanding what I'm doing now. But I want to explain to you properly what we're doing. So if I move that triangle, then that triangle will go here somewhere. I've taken that hypotenuse side and flipped it. This angle here was 60 degrees. Now I'm taking the hypotenuse side and flipping it over another 180 degrees. You see what I've done? I've taken 60 degrees and I've added 180 degrees. There's the 180 degrees I've added to the 60. So it's 60. There's the first 60 and adding 180 degrees. So this angle becomes 60 here. This is 1. This is minus root 3 because that's a y section. And this is 2. Can you see what I've done?
Mm-hmm.
So basically, I can still use my 60-degree triangle, my special triangle, to calculate cos of 60. But I can also calculate sin of 60. I can also calculate sin of 180 plus 60. It is just going to be this red triangle, which I'm now going to color in with green. It's just this triangle. I'm just using that triangle to calculate 180 plus 60. So it's still going to be sin 60, but my quadrant belongs to tan, which makes sin negative. So that is going to be the same as negative sin 60. You see that?
Mm-hmm.
So sin of 60 was root 3 over 2. Now it's going to be negative root 3 over 2. That is negative root 3 over 2. But now students don't want to do this. All the work that I've just done in the head or on paper is really kind of unnecessary. So the easier way, or the easy way to do this is just to do the following. I'm just going to go back to the sum to start off. Say, look, there's two ways of doing it. Sin 240 can be divided into sin 180 plus 60. I'm always going to try and use 180 or 360 plus minus. And then later on 90 and 217. I'll show you 90 and 217 in a minute. And that is in the third quadrant, which makes my sin ratio negative. And that becomes negative sin 60. And then I use my special triangle, put a negative in front, and sin of 60 is root 3 over 2. So make a note of that. So the quadrant number determines the sign, a plus or a negative. So we are going to play around with a couple of examples. And then we see what you can do. These sums will count the most of all the trig sections. Count a lot of marks. And then you tell me when you're ready.
Yeah, you can move on.
Okay, let's do another one. Cos of 150 degrees. Well, that is the same as saying cos of 180 minus 30. Is that, where did I get the 30? Well, I remember that my triangles have a 30 degree in it, a 60, a 45, and a 90, a 90, and a 0. Those are the angles I can use together with 180 or 360. Happy with that?
Mm-hmm.
What quadrant number is that? 1, 2, 3, or 4?
Is it not 3?
180 minus is in the second quadrant. Look at this.
Oh.
I know it's funny. You move clockwise for negative to subtract. So that will bring me into the second quadrant. Happy?
Mm-hmm.
Okay. What is cos then? Positive or negative? Seeing that the quadrant belongs to sin only.
Is it negative?
It's negative. And then cos 30. So it's negative, and then I have to draw that special triangle. 60, 30, 1, 2, root 3 to get the, then I do cos of 30, is adjacent over hypotenuse, it's root 3 over 2. Now, what you can do to check your answer is just type cos 150 in your calculator. And see if you get the same answer. Good. Then you know the answer is correct. That was quite easy. Checking the answer.
Yeah.
But you're not allowed to do it without a calculator. You can't just write the answer. Then they know you've used a calculator, and in these sums, you're not allowed to use a calculator. Okay, let's do something interesting. Tan 480 degrees. Now, 480 degrees is way more than one circle, is it?
Mm-hmm. Yeah.
So let's assume that I have an angle here, any angle, it's called X. If I add 360, can you see I end up at the same spot, exactly the same spot? That was adding 360. If I subtract 360 degrees, so minus 360, and the other one was plus 360. If I add or subtract 360 degrees, I end up exactly where I was. Why? Because I just added one full circle. So I'm allowed to add and subtract 360 degrees whenever I want to. So I'm going to make that angle smaller by just subtracting 360. Then I get what? 120. So I'm not even going to show what I've done. I'm just going to subtract or add a 360 degrees whenever I want to. And now I can work with that angle, can't I? That is the same as tan of what? Try and mix up either 180 or a 360 with one of those special triangle values. Can you help me, Amira? Which one are you going to use? Is it 180 plus or minus what? The 120.
You would minus it though.
Yes, with what? 30, 60, 45, or 90, or 0?
60.
60, it's good. And then I get what? What quadrant is that? 1, 2, 3, or 4?
Wouldn't that be maybe
2?
Oh, would it be 1?
No, it would be 2.
1 or 3? Oh, it's 2.
Okay. Right. Show you another method in a second. Okay. So that is what? Negative tan 60. Why? Because only sin is positive in that quadrant, and tan would be negative. And that would be negative, and the tan 60 is root 3. Okay, let's redo this sum slightly different. You might gonna like this more. Okay, let's focus on this system of axes quickly. And let's restart the sum here at a tan 120. Okay, you understand how we got that tan to 120?
Yeah.
Okay, now forget about the 180 minus 60. Forget about that now, for now. Look at that system of axes and tell me in which quadrant number would you find 120 degrees?
2.
2. That's easy. That's how I do it. 2. It's correct. Is tan positive or negative in 2? Seeing that only sin is positive.
It's negative?
It's negative. So my answer is negative. Can you give me what angle do I have to add to 120 to get 180?
60.
So that's negative tan 60. So I'm skipping that 180 minus 60 because it's a lot of work extra. And that is negative. And then I go to my special triangle where I have a 60 degree, a 30 degree, a 1, 2, and a root 3. And then I read tan of 60 from that triangle, which is root 3 over 1, or just root 3. That wasn't too difficult.
Mm-mm.
Good. We'll try another one. Okay, now, what about cos 300? Let's make it cos square 300. I'm going to show you how to rewrite that. That is the square of cos 300. That's kind of important. Good. Let's do it your way. What quadrant number is 300?
C.
C is correct.
I mean 4.
4 and C, same thing. As long as you know which one is positive there. Cos is. So my answer is going to be positive. Because cos is going to be positive. Give me the difference up to 360.
Meaning?
What would I, if I want to write something there, how can I, what angle can I add to 300 to get 360? Or what would you have written there? Remember, I have to add one of these 3 angles or subtract them to get up to a 360 value or up to a 180 value.
Why don't you just do it with 60?
Can I just add 60 now?
Yeah.
Okay. So that would be square of cos 60. Oh, that was a lie. I could not write that. That was just dumb. Can't do that. Can't say, I must just write cos 60. And that is half square on that triangle. Cos of 60 is half. That is a quarter. Okay, I'll show you other method. The other method was this.
If you just put your answer as a quarter and you don't put 1/2 squared, would that be fine?
No, you have to put in this value here. That one you got there.
Oh, okay.
Because that's just to show that you've used a special triangle. I know, just slept. We're just going to redo this. See if you're now used to that other method. So cos squared 300 was the square of cos 300. Now, 300 degrees is the same as saying 360 minus 60 squared. So I have the square, that is 4th quadrant or C's quadrant. 360 minus 60 is C's quadrant, or you can just look at the 300 degrees and see it's cos's quadrant. So cos is going to be positive 60. If I put that into my special triangle, I get a half square, and that is a quarter. Make a note of any one of those 2 methods.
Okay, I got it down.
Okay. Would you have 1 or 2 more of these elementary ones? Okay, now I'm going to do, let's say, sin of negative 30 degrees. Now that's the same as saying sin of 0 degrees minus 30 degrees. That's exactly the same. Minus 30 just means 0 minus 30. And 0 is there. You see that?
Mm-hmm.
So 0 minus 30 is the 4th quadrant, which makes my sin ratio negative because only cos is positive. So that's negative sin 30. That is negative, and then sin of 30 I can do from that triangle. That's a half. Good. Write that down.
Okay, I got it down.
Okay, now there's another way of doing it. Let's just paste this here so we can use it. Oh, that's ugly now. Let's just delete it. Okay. Right. I can also give it to you like this. I can also say, let's do sin of 180 plus theta, which is unknown. Now, in algebra, we normally use x, y, and z. in geometry or trigonometry, we use theta, alpha, and beta. But you can also use X, Y, and Z. You can use any unknown, really. Similar, like in algebra, I can use any unknown. Okay, now that theta or unknown just represents an acute angle. So I'm going to start with 180, and then I'm going to add an acute angle. That means I'm ending up in the third quadrant, which belongs to tan. And that means sin is negative. Are you happy with that?
Mm-hmm.
So that's just negative sin theta. And that's your answer. Okay. Now, there are two more things that we have to learn now to continue. And that is the one thing is that tan can always be changed into sin divided by cos. And sin square x or theta or any unknown plus cos square is 1. Those are two identities that you have to learn in grade 11. And you have to write them down. They are additional stuff to learn. So there's going to be a lot of work to do. Now, Ibrahim needs to catch up.
Yeah.
Is he going to be away for 10 days?
No, he'll be here next week.
Are you friends?
His 10 days ends on Eid's day. So that's Monday or Tuesday.
Who's Eid?
Eid is it's like Christmas for us, basically. That's when our fast ends.
Oh, yeah. All right. Okay, you got those two. So say, for instance, I have tan 180 plus theta times cos minus theta divided by sin theta. Let's say just 180 minus theta. Let's do that sum. That's about 4 marks. Okay, now check. Look what I'm doing. Tan 180 plus theta is in the third quadrant. Happy with me? That means my tan ratio is positive. So that's positive tan theta. Minus theta is the same as 0 degrees minus theta. That's fourth quadrant. So therefore cos is also positive. 180 minus theta is in the second quadrant. That means sin is positive. So that's positive sin theta. Okay. But now tan can be converted into sin divided by cos times cos. Oops. Divided by sin. So those two cancel. You understand that?
Mm-hmm.
And sin divided by sin is also canceling. So our answer is just 1. Please write that down.
Okay, I got it.
Good. Let's make this kind of small. So now I can actually mix them up. I can say sin of 150 degrees times cos of 180 minus x divided by, let's say, cos of 480 degrees. Okay, do you want to try that one on your own? I think so. See what you can do on your own. I'm just gonna go to another screen. I'm not sure if it's pausing or not.
It's on the same page.
So nothing's happened. I don't know why it's sometimes just interesting thing. Now it's, I don't know why it's still blocking. Just tell me quickly, Amira, can you see me writing on the screen now?
Yeah.
Okay, I got it. I understand what's happening. If I go full screen on some other app, then it blocks, it stops the screen. But if I don't go full screen, it doesn't block the screen.
I don't know if I did this right.
Okay, well, we're going to do it step by step. Is there something you can do with 150 degrees? Did you write it? Did you compound it first by 180 minus 30, or did you just do it straight?
I first did that and I got 1/2.
Which is 100% correct. Sin of 150 is the same as 180 minus 30 now, isn't it?
Yeah.
Okay, then cos of 180 minus x, that is second quadrant, isn't it?
Mm-hmm.
So that's negative for cos. Is that correct?
Yeah.
Then the 480, I just subtracted 360 again, and then I got 120. Correct?
Mm-hmm.
Okay, this is second quadrant. So it's positive sin 30 times negative cos x. This one at the bottom is also second quadrant, which makes it negative cos. Okay, well, let's just do that long method first. That 120 is the same as cos 180 minus 60. So on top I have sin 30, which is half, times negative cos x. At the bottom I have a negative value because that's second quadrant, which makes cos negative. That's negative half. Okay, yeah, but I'm not allowed to skip that step then. I'm just going to write it, negative cos 60. This gives me half times negative cos x on top and negative half at the bottom. And that gives me cos x as an answer. Did you get that?
Yes, I wasn't wrong.
You were right.
Yeah.
Awesome. Okay. One more thing we have to learn today. It's a problem now. There's a lot of new things. You must really tell Abraham that if he doesn't go through this work by next week, then he will really be feeling that he's fallen behind. Good. Okay. Now we've just used, at the moment, we've just used 180 and then either a 360 or a 0 degree to add and subtract. Happy.
Mm-hmm.
Now we're going to use 90 and 270. Now, if we do 90 plus minus an angle or 270 plus minus an angle, we do co-functions. Co-functions is from the word co-interior angles. So that means that sin changes to cos and cos changes to sin. So sin and cos swaps around if we use co-functions. I'll show you a couple of examples. So look at this. Say, for instance, we had sin of 120 degrees. Then we could have done it the following way. We've done it now a couple of times. This was the same as sin of 180 minus 60. And that's second quadrant. So it's positive sin 60. And that is root 3 over 2. But you could have done the following. It would be rather dumb to do it, but it's possible. Well, it's not wrong, it's right. You could have also said that 120 degrees can be divided into 90 plus 30. See that? So let me just draw the special triangle. The special triangle is the 60, 31. 1, 2, root 3. Okay, that is also second quadrant. Obviously, because both is 120 degrees, it must be the same quadrant. Can't be different. And sin is positive in the second quadrant. But sin changes to cos because I'm using 90 plus minus. So that becomes cos 30. Now, if I read cos 30 off that special triangle, I get the same answer. So this is an or statement. You can use any one of those methods. I will always use this method. It's preferable because then I don't have to do the co-function. But sometimes I'm going to force you to use the co-function. I'll give you an example in a minute. Just make a note of that. So this one is the best method.
Okay, I got it.
Tired, Amira?
Now it's
Yes.
just like
Huh?
sitting up straight
Sitting up straight.
or more straight.
Good. Okay, so say for instance, I've got something like this. Sin of 40 degrees times cos of, let's say, 240 divided by cos of 130 degrees. That is dumb. It's not that dumb. No, it is dumb. Okay, let's see how dumb it is. Okay, right. So now the immediate thing that you see is that I have a sin 40 degrees there, which is acute, but I don't have an angle for that. My special triangles only have 30, 60, 90, etc. I don't have an angle for that, which is kind of worrying, actually. Is it? No, it's not. If you get an angle that you can't solve with a special triangle, that is going to cancel. So don't worry about that. So now I also have cos of 240, which is the same as cos of 180 plus 60. And then cos 130 is cos of 180 minus 50. Is that correct?
Mm-hmm.
But 50 is another problem. Potential problem. Okay, so at the top, I have sin 40. Then I have second quadrant, which makes that negative cos 60. And at the bottom, I have second quadrant, which makes that negative cos 50. But now look at this. Look at the following. I can change that sin 40 into sin of 90 minus 50. That's 40 degrees. And then at the bottom, I have negative cos 50. I'm just going to rewrite there. Then this is first quadrant. So everything is positive in the first quadrant. 90 minus acute angle is first quadrant. But sin becomes cos because it's a co-function. So that's cos of 50 times negative cos of 60 divided by negative cos of 50. So those cancel at the end. And a negative divided by a negative is a positive. So my answer is just cos 60, which I can read from that triangle, which gives me a half. Please jot that down. And then I'm going to show you what the examples look like that you're going to get in the test. They are lots of marks. They are between 5 and 7 marks each. And once you can do this section, you are going to be what? freaking out because you're going to get a lot of marks. It's going to be really easy. Okay, write that. Now what? Screen sharing is paused. You are screen sharing. That is so interesting.
Okay, got it down.
Okay, good. Okay, let's see. I just want to see if I've got a section here for reduction values. No. I need to make a new... okay, let's just continue. There we go. Okay, I'm going to copy something. I think your screen might go blank. I'm not sure. Does your screen go black? Hmm?
No, it's just a new page and I can see you pasting.
Okay, wonderful. I'm getting the grips of this. Okay, I think you can do everything. The two things you have to spot is there's a sin 20 there. I don't have a special triangle for it. And there's a cos 70 there. I don't have a special triangle for it. They need to be reconfigured so that they cancel. Then I have other interesting angles as well, which kind of problematic or looks kind of problematic. But I want you to start and do as much of the sum as you can. You have your special triangles in front of you and your system of axes. Don't be thrown over by that 270, eh? You will, there's many ways to solve that. See how far you can actually get. Okay, can I help you with something?
Yeah.
Okay, look, it's going to be normal to struggle with this for now. So that is just sin of 360 minus 30. The most important thing is to take one step at a time and not to try and change everything at once. So that sin 20 is already acute, so I'm just going to leave it. The cos 0, well, I have a special triangle for 0 degrees. Maybe you forgot about that one. 0, 1, 1. Cos of 0 is just 1. And later on, you are going to do the cos graph, which looks like that. And that's just going to be 1 at 0 degrees. So you'll get the graph or that special triangle, because that's sorted. And now sin of 270 in many options. So you have many options. Which one?
Minus 90. 360 minus 90.
360 minus 90. Okay, that's an option. You can use 270 plus 0. You can use 270 minus 0. You can use 360 minus 90. You can use 180 plus 90. All of them is 270. That's awesome. Okay. Then cos 70, I'm going to bring 20 degrees into the sum. That's the same as saying cos of 90 minus 20. Good. So now I have sin of 360 minus 30. That's fourth quadrant, so making it negative sin 30. Now sin 20 is just going to leave. I'm going to wait for it to cancel, and that one I'm going to ignore. Then that's fourth quadrant. I'm not adding with 270 or 90. I'm taking 360 minus. So that becomes minus sin 90.
Mm-hmm.
And then that is first quadrant. So that becomes positive, and everything is positive there because all is positive. Then that becomes sin 20. So those two are just going to cancel. And then I have a negative and a negative. Oh, anyway, I've got the 90-degree angle already. So now I need my 30-degree triangle. So that's 60, 30, 1, 2, root 3. So minus sin 30, sin of 30 is root 3 over 2 with a negative in front. And at the bottom, sin of 90 is 1, so that's minus 1. And the answer is just root 3 over 2. If I put all of that in my calculator, then I'll get the same answer.
Okay, the only mistake that I did was cos 70.
Oh, you didn't change that?
Yeah.
Okay, but you're doing well then. Good. Maybe there's time for one more.
Okay.
Okay, let's just do a small one. Cos of 90 plus alpha divided by sin of minus 60 degrees. Let's say times tan of negative alpha. Okay, let's do this one together. You can help me. What quadrant number is that? 90 plus alpha.
Oh, wouldn't that be a negative?
That would be a negative because it's in quadrant 2, isn't it?
Quadrant 2. Yeah.
So that becomes negative, but cos changes to sin because there's a co-function. It's 90 plus minus. So that becomes sin alpha. What quadrant is negative alpha?
I'd say the 1 or 3.
Nope.
Oh.
The same as saying 0 degrees minus alpha. Fourth.
Oh.
So that's negative tan alpha.
Yeah.
Then what quadrant is minus 60? Also 4.
Yeah.
So that's negative sin 60. Now, on top, I have negative sin alpha times negative. Tan is going to change to sin alpha over cos alpha. And at the bottom, I have negative sin 60, which I need a special triangle for. 60, 30, 1, 2, root 3. And that is negative root 3 over 2. A negative and a negative makes a positive. I don't like this sum. I've stuffed it up. Then, if those two sins multiply, I get sin square x. And the bottom of that, I have cos x. And that I'm going to divide with negative root 3 over 2. And that means if I rework that sum, I'm multiplying it with negative 2 over root 3, isn't it?
Mm-hmm.
So I have 2 sin square x over with a negative root 3 cos x. Okay, so that was a made up sum. And that's why it's got a funny answer. Okay. Right, we are going to work on this again. Next week, we're doing other stuff. But in the meantime, I want you, if you're going to start with trigonometry, start with this section on reduction values, okay? Don't start with triangles or anything else.
Okay.
Good. Have a great one.
Okay, you too.